In the example 1, you used pure command to find a property of a pure component. But what if you want to find more than one property for a mixture? You might need another type of analysis. In example 2, the task is to find a specific volume and heat capacity in metric unit and also compressibility factor of a mixture containing 630 kmol per hour of carbon monoxide, 1130 kmol per hour of water, 189 kmol per hour of carbon dioxide, and 63 kmol per hour of hydrogen at 1 atm for the temperature range from 400 to 600 Kelvin. So the question is, which property method should be used? Since the pressure is low, an ideal gas is probably sufficient to represent the system, but we will also use RK-Soave to make a comparison. We will perform this task by, again, adding components and property methods. As there are more than one property, we will create a property set to collect all properties we want to analyze. And finally, we will use the property analysis of a mixture to perform this task. So let's return to ASPEN Plus. With a new simulation, go to Setup to set the unit of measurement as metric units. Then click Next. It will navigate you to Components and Specification form. So enter CO for carbon monoxide, H2O for water, CO2 for carbon dioxide, and H2 for hydrogen. Then click Next. It will navigate you to Method and Specification form. Choose Ideal. And then click Next. After that, since there are more than one property, we will create a property set to collect all properties we want to analyze. Click Property Set folder, and then click New, and enter the name PS1. Double-click PS1. Then click Search for the property you want. So first, we're looking for molar volume of a mixture. And then heat capacity. Of a mixture. Click OK for this. And then compressibility. Compressibility factor of the mixture. So select the unit. For the heat capacity, select Joule per kilomole Kelvin and specific volume for cubic meters per kilomole. Click Next. For the quantifier, click Vapor After we have completed all required input, we will next perform the property analysis of the mixture. Then click Mixture command in the Analysis ribbon group. The Mixture 1 input form will then appear. Under Mixture Sheet and Composition field, for the basis, leave as default for the mole basis and kilomole per hour for the unit. Enter all components and their associated flow rate. And the flow rate is 630, 89, and then 63. Okay. After that, go to the Manipulate variable and select Temperature. Select Equidistance, and with the starting point of 400 Kelvin, aim at 600 Kelvin with increments of 20 kelvins. In the parametric variable, choose pressure with ATM and then leave it like 1 ATM. In the Properties to report, select PS1, then click Run Analysis. The graph plot between specific volume, heat capacity, and compressibility factor versus temperature will then pop up. You can see that when the mixture plot sheet is active, the plot bar containing the Design and Format ribbon tab will then appear. The commands under these ribbon tabs allows you to customize the format of the plot. For example, if I want to change the interval between the value of temperature shown in x-axis, I just simply click the axis and then put the interval to 20. You can see that as the temperature gets higher, the specific volume and heat capacity also increased. But the compressibility factor is always 1, since this is the model of ideal. So the compressibility factor is always 1. Let's go back to the Mixed 1 Input tab and look for the result. This is a data table that used to create the plot. Next, I will use another type of form to create another property analysis by using RK-Soave equation of state. Go to Analysis folder, then click New. Select Type as Generic, and I will change the name to RK-Soave. Click OK. Here, I'll select points along a flash curve, and then I will put the flow rate here the same as in the mixture. But I will go to the mixture input, then copy the flow rate here. and will then press straight away. Click Next. In the Variable tab, for the fixed state variable, select Pressure and then enter 1 atm. For the adjusted variable, select Temperature. Click the box under Component and then click Range/List. Choose the Specify Limits with the lower of 400 and upper at 600 and the increment of 20. Click Next. Next again. For the Tabulate tab, select PS1 as the property set to be analyzed. In the Property tabs, choose RK-Soave. Then click Run. You can check the result of this calculation by going to the Result tab. And this is the table of data that was calculated by RK-Soave equation of state. You can see that the analysis with a generic type can do the same task as mixture command. This is because a generic type provides a more general approach to customize the analysis, where the mixture command is only decided for the analysis of a mixture. Next, I just want to compare the result between the RK-Soave method and ideal method. I will drag this sheet here to become another separate window. And this is for RK-Soave. And then I will go to Mixture Input. Go to Result tab. And then make a comparison. You can see that the value of the specific volume predicted by ideal property methods is quite similar to the one predicted by RK-Soave. As well as the heat capacity. But the one that is different is the compressibility factor, which in ideal present as 1 and in RK-Soave is about 0.998 something. So this is present the non-ideal behavior of the system predicted by RK-Soave.